All right, this is circuit number 14 from the Chapter 6 DC combination math handout. So we see here, this is the original drawing we're given, and here's our known values down here. Now this is a basic combination circuit, so my first value to find is going to be RT, and I'm going to leave power till last. So trying to find RT, the first thing I look at is I see that R1 and R2 are actually in parallel with each other. Remember that the definition of a series circuit is there's only one pathway for current to flow through, and the definition of a series circuit the definition of a series circuit is there's only one pathway for current to flow through. So right here, there's only one pathway. That tells me R3 is series. The definition of a parallel circuit is there's more than one pathway. Well, for R1 and R2, there's more than one pathway. So that tells me R1 and R2 are parallel with each other. So the first thing I'm going to do is I'm going to reciprocate R1 and R2 together. So I'm going to say 1 over under 1 over under 2.2 k ohms. Scroll over plus 1 over under 3.3 k ohms. And that tells me that the reciprocation of R1 and 2 added together, not added together, but reciprocated together, is 1.32 k ohms. So this value right here comes from these two reciprocated. Now my R3, I didn't do anything with him yet. I just brought his value straight over. So now this gives me 680 ohms in series with 1.32 k ohms. What do I do with resistors in series? I add them together. So if I add 1.32 k and 680 k, my total resistance is 2 k ohms. That's my first step right here, RT. Now remember, any resistor on the main branch, well, all right, so my next thing I can solve for is IT. So I take the 15 volts divided by the 2 k ohms, and that tells me I have a total current of 7.5 milliamps. All right, now any resistor on the main branch is going to have the same amount of current flowing through it as IT. Well, in this case, R3, you can look at how the circuit is laid out. All the current has to go through R3 before it can get to here and split. So R3 is on the main branch in this instance. That means that I3 is going to have the same current as IT. So I used Ohm's law to find IT. Then the next thing I did, I realized just by understanding my principles that I3 is going to be equal to IT. Now I've got 2 out of 3 to solve for V3. So I take the 7.5 milliamps times 680 ohms equals, hit engineering, and that tells me that 5.1 volts are going to be dropped at V3. Now since V1 and V2 are parallel, that tells me that V1 and V2 will have the same amount of voltage, but it can't be the full 15 volts because I dropped 5.1 volts at R3. So this tells me that V1 and V2 will be the same amount because they're in parallel. V1 will equal V2. But I've got to take the VT and I've got to subtract V3 from it. So I take the 15 volts minus 5.1 volts, and that tells me that both V1 and V2 will be 9.9 volts. So looking at my steps up here, I used Ohm's law to solve for V3. Then I'm going to understand that V2 equals V3, which equals VT minus V3. So that's how I got 1 and 2. Now I've got 2 out of 3 to solve for I1, and I've got 2 out of 3 to solve for I2. So I take my 9.9 volts divided by 2.2k ohms, and that tells me that I1 is 4.5 milliamps. So if we look at the current flow through this circuit, from here to here, I'm going to have 7.5 milliamps in this part of my circuit. Now I just calculated that 4.5 volts is going to go this way. This way. Well, if 7.5 came to this point and 4.5 went up here, how much must be left over to go down here? It would have to be 3 milliamps. But we can do the math just to make sure. 9.9 divided by, and I'm going to scroll down and over, and I'm going to divide 9.9 by 3.3K, and it comes out to be 3 milliamps right here. So 7.5 milliamps comes this way, 4.5 goes up top, and 3 comes down this way. It all comes back together, and then 7.5 milliamps flows from here to here. All right, the only thing left is power, PT. So now I can do power. PT is equal to IT times VT. So if I take my IT of 7.5 milliamps times 15 volts, that gives me that. P1, I1 times V1. P2 is I2 times V2. P3 is I3 times V3. And I should be able to add P1, P2, and P3 together and get PT. Now, the reason why I have these 3 values right here is because that's all I asked for on the homework or on the test. But really and truthfully, you should find everything, all the values, check your work, and then provide the answers asked for.